Hello friends, welcome to my channel. Let's have a look at problem 143, reorder list. So here the list is actually a singly linked list. So in this video, we're going to share a solution based on linear traversal and reversal. So first, I'll read through the problem statement to digest the requirement, and then we go over the analysis, and finally we share the code. First, let's look at the statement. So we are given the head of a singly linked list. So the list can be represented as L0 connect to L1, then connect to Ln-1, then to Ln. So reorder the list to be on the following form. So we connect the head with tail, then head with tail, and so on. So we get L0 connect with Ln, then Ln connect with L1, then connect with Ln-1. So that's the requirement. So we may not modify the values in the list's nodes, so only nodes themselves may be changed. So here are two examples. So in the first example, the linked list has length 4. So the return is 1 connect with 4, then connect with 2, and then connect with 3. So this is the result. And in the second example, the linked list has length 5, which is an odd number. So we first connect 1 with 5, then 5 connect with 2, 2 with 4, and 4 with 3, 3 with null. So this is the return. So with that said, let's also look at the constraints or additional assumptions for this problem. First, the number of nodes in the list is in the range between 1 and 5 times 10 to the power 4. So this constraint actually defines the problem size. And the second constraint is on the node value range, which is in between 1 and 1000. So with that said, we are ready to look at the analysis. So this problem actually is very interesting. So the solution is based on linear traversal with reversal and merge. So here in this solution, we are going to practice several things. First, we are going to practice slow fast pointers technique. And then we practice how to reverse a linked list. So also we practice how to merge linked lists. So here we merge two linked lists. Actually, there is a problem in Leetcode which requires to merge a number of linked lists. So it might be useful to check the corresponding list in our channel if you have time. So for this problem, the procedure is the following. So first, we'll find the middle node using slow fast pointers method. So if we are using zero indexing, then the index of the node, the so-called middle, is n over 2. So here over means integer division, and n is the length of the linked list. So for example, if the linked list has length which is an even number, so for example 0, 1, 2, 3, so the mid is in this node 2. And if the linked list has length which is an odd number, so for example 5, so 0 connect with 1, with 2, with 3, with 4, then the middle is again this node with value 2. So this is the first step. The second step is that after we locate the middle, then we're going to reverse the linked list represented by the middle node. So if we use example 1, so we can fix the idea as below. So this is the original linked list. So the middle is 3. So then we break the link between 2 and 3. And then we reverse the second half. So we will get two linked lists. One is represented by the original head. So that is 1 connect with 2, then null. The reversed one is nothing but 4 connect with 3, then null. So this is the second step. The first step actually is routine. So we're going to merge the two linked lists obtained with alternate nodes from the two linked lists. So we connect 1 with 4, and then we update the heads correspondingly. So then we connect 4 with 2 and 2 with 3. So we are done. So this is the third step. So here actually there's a remark. So it's possible that the second half of the linked list is one longer than the first half. So when the original linked list is of odd length. For example, if we use example 2, so the first half will be 1, 2, and the second half after reverse will be 5, 4, and 3. So which has length 3. So we just need to connect the last node after we exhaust the first linked list and all other nodes except the last one in the second linked list. So this is actually a thing that is very easy to do. So with the above procedure specified, so now we are ready to write the code. So as required by the problem, we are going to do the things in place. So we are going to write with some detail and explain the code line by line. So in the process, we are going to write some annotations. So first, so we are going to find the middle, the so-called middle node, using slow, fast pointers. So this is actually a very routine technique. So if you practice quite a lot, so you can write it with ease. So here, in order to do this, I'm going to initialize a variable called previous. So because I need to break the link when we do the reverse in the second step. So previous originally is none. Then we're going to initialize a slow and a fast pointer, initially both pointing to the head. So notice that the head is not null at the very beginning due to the problem requirement assumption. The number of nodes is at least 1. So the linked list is not a null list. Then we can do the standard slow faster technique, while fast and fast next. So you notice or understand this condition after the next 2 lines. So we're going to update the pre to be slow, and the slow move to 1 step further. So slow next, and then we update fast to be fast next next. So that's why we have this condition, fast and fast next. Because of this condition, fast next is not null, so we can consider fast next and its next, right? Because this part here is not null. Otherwise, we cannot do this. So after this while loop, so actually the slow corresponds to the middle node, and if we use this one as example, this will be the slow, and this will be the previous. So before we do anything, let's first treat a special case. If pre is null, so in this case, it means that the linked list is too short, so just have 1 node, so we just need to return the head in this case. So this is actually very easy. So now, up to now, so we have this. What we want to do next is to break the link first. So this is the pre, you can imagine, and this is the middle. So we want to break this link. So previous next, we'll set it to null. So then we can actually get the corresponding information for the first half of the node. Let's print out that just for examination. So if print head, so this head will represented by 1, 2. So let's do a check. Yeah, this is 1 and point to 2. That's everything is right. So with that said, let's do another thing, do the second step. So now the second step is to reverse the linked list headed by the middle, that is the slow, right? So we're going to do reverse. So for this, actually, let's first introduce a dummy variable. Let's call it null. Then we're going to do the reverse. So this is actually very routine. While slow. So slow is the linked list head, right? So while slow, so what we are going to do is that first let's save slow next for later use, and then we connect slow with dummy. So this line actually did two things. First, it breaks the link of slow with slow next, and then we point slow next to be dummy. So after that, we can update dummy to be slow and slow to be temp. The temp is the original slow next, right? So this is the standard way of reverse a linked list. So after that, because if we exit this loop, slow will be null. However, the dummy is not null, right? So the dummy will be the head of the reversed linked list. So let's print this out just for a check. It's a dummy. For example 1, the dummy will represent the 4 pointing to 3. Let's do this check. So you can see this, the 4 point to 3. Everything is right. So now with this done, so we can do the next step. So the next step is merge the two linked list headed by the original head as a dummy. So for this merge, actually it's very simple. We just need to use alternating nodes from the two nodes. And for this purpose, I'm going to use a auxiliary node, so and also make it a start, so to be list node. So I'm going to use the default initialization data. Then we're going to check the head. So the head is the first half, and dummy either have the length that is equal to the length by the head or one longer. So anyway, so we just need to use head as the check condition. So while head, so what we're going to do, first I'm going to save the the head next and the dummy next. So it's head next and dummy next. So this is the save for later use. And then what we are going to do is we connect the next to be head, and then we connect the head next to be dummy. So after we do this, what we are going to do is that we set the aux to be the dummy, and then we are going to update the head and dummy to be temp1 and temp2. So from this line, we can interpret the purpose of the first line after the while condition. So that's about it. So we have so here what we are doing is that save temp1, temp2 for use later, and set aux next to be head and connect next with dummy, and then we update the aux to be the current dummy, and then we update head and dummy by temp1, temp2 saved earlier. So that's the case. So after we exit this while loop, so the first linked list is exhausted, but the second might be not. So if the second is exhausted, so we are going to have dummy is empty. So if not, so if dummy, so the dummy will be the last node in the second list. So we are going to connect aux to dummy. So this way, actually, we merged the two linked lists. So we are going to use this aux as a moving variable. So when we do the return, we are going to return start next, right? So the return is simple. So we are going to return start next. So this up to now we finished the overall logic for this problem. So now before we make some comments, let's first do a special case check. Yeah, it passes the first example. Now let's look at the generic case. Yeah, it passes all the cases. It should be reasonably fast because it's a linear method. So anyway, so before we end this video, let's overview the structure of this solution. So we split the logic into three parts. So the first part actually is a standard practice of the slow fast pointers technique, to locate the middle node. And after the first step, we're going to reverse the second part of the linked list to prepare the merge. The third step is to do the merge of the two linked lists by alternating nodes from the two linked lists. And afterwards, we return the desired result. So in the process, actually, we used the dummy node twice at least. For example, when we do the reverse and when we do the merge. So this technique or trick is very useful sometimes when we do linked list problem. So with that said, I guess that's about it for this video. Thank you very much.